Hello, let's continue our Sudoku adventure with The Riddle of the Sphinx by Jean. We are back to our normal rotation puzzles. I hope you enjoyed the holiday theme that we had for 25 puzzles in a row. I definitely enjoyed it. All right, well, let's go over the rules to this puzzle. So we have normal 6x6 Sudoku rules. So in each row, each column, in each 2x3 box, we are placing the digits 1 to 6 exactly once each. I also have these yellow lines in the grid. These are anti-factor lines. So yellow lines in the grid are anti-factor lines. The digits along an anti-factor line of length n must not include any factor or multiple of n other than 1, and must sum to a multiple of n. Digits may repeat as normal. So we don't have any special non-repeat rule on these lines. So n is equal to the length. So let's just use this as an example. This is a length 4 line. And so what are the factors of 4? They are 1, 2, and 4. But we can ignore the factor of 1. We're allowed to put 1s on the line. But we're not allowed to put 2s or 4s on the line. You also can't put any multiples. So we wouldn't be able to put an 8 on the line. Or a 12 or 16. But obviously, we don't have those digits anyway. So in this case, this line bands 2 and 4. And in addition to that, its sum needs to be a multiple of n. So it sums to 4 or 8 or 12 or 16, etc. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. I want to start with this little itty bitty line. This is a 2 length line. So you can't put any even number on it, right? You can't put a multiple of 2. And so it's just got odd numbers on it. And it has to sum to a multiple of 2, but that's always going to be true of 2 odd numbers because 2 odd numbers add to an even number. And by definition, an even number is divisible by 2. So this is just odd. I guess we should think about this 4 length line. We also have this 4 length line. So it doesn't have, none of these cells have 2 or 4 on them. So they're from 1, 3, 5, 6. We can just pencil that. And so the 4 in this box goes here, and the 2 in this box goes here. That places the 2 in this box here. All right, and this is the other 1, 3, 5, 6. So is this. Let's see. 4 is in one of these two. Okay, so this line is how long? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is 10 long. So it doesn't have 2 or 5 on it. So let's just pencil it with 1, 3, 4, 6. It's not a 4. This is a quad. That's not a 4 either. This is a 1, 3, 4, 6 quad. So 2 and 5 go over here. So that's 5 and that's 2. So this is a 1, 3 pair. That places 6 here. None of these are 6. It's a 1, 3, 5 triple. We'll look at this a little bit more in a second. This is 5 for this box. All right. This is a 1, 3, 4, 6 now. So this is where the 2 and 5 go. This is 2. This is 5. That's not a 5. That's not a 5. All right, 1, 3, 4, 6. Oh, we need a 2 in this box, which only go here. I finish the 2s? I should be able to. That's a 2. All right. 2s are done. What about 5s? 5's in one of these two. 5's one of these two. Maybe I'll mark that. That might be interesting. So let's think about this. Yeah, okay. So if it's this has to sum to something divisible by 4, which means it's going to be even. And these two are odd for sure. And so they're going to add to an even sum. And so these two need to also add to an even sum. So even plus even to stay even. And so we know there's a 5 on it. So it's got to be 2 odds. So it's not going to have a 6. And that places the 6 here. That's not a 6. All right. And now, can we think about this further? Is there more to even and even? Maybe this one. Well, that's not 6. I can place the 6 here, actually. Maybe we can just do our Sudoku. That's not a 5, so it's 1, 3, 4. Is there more to do here? Do I need to think about this further? Trying. So we know a 5 is present here. 1, 3, 5. Okay. What if this didn't have a 5? I guess is my first question. I'm trying to figure out where this 5 goes. Is there a better question to ask here? 2s and 5s. Maybe. Got this 6. This sums to a multiple of 4. So this has to be even as well. Okay, so actually I have some kind of parity argument I can make probably. Let's see. So this totally sums to an even. Without this 6, it still has to sum to an even, but this is odd. So these two together sum to an odd digit, which means these two need to sum to an odd digit. Well, we already know from the column they contain the 6, and so it's going to be either 6-1 or 6-3. I don't know if I can really case check that right now. I'm not sure if it's worth it. There might be something easier. We know 4 is in one of these two. What can we do about that? 1, 3. There's probably something I'm missing. 1, 3, 5 triple. Oh, of course. This is a 1, 3, 5 triple, and that adds to. I kept grouping it by box because I had done that earlier. But this triple, we know what this adds to. It's 1 plus 3 plus 5. So that's 9. And so we can't do 9 plus 1. That would be 10. 9 plus 3 would be 12. That's fine. 9 plus 5 would be 14. That's not fine. So this has to be 3, which does place the 5 here. This is 1 and 3. None of these are 3. This is our 5 for the box. And that places the last 5 there. This is a 3. All right, that was an important deduction for sure. All right. Now, what are we doing? Maybe think about this line then. Yeah, so this is a 5 now. This adds to 11. We have to get to a multiple of 4. So we need to add 1 or 5 or 9. Okay, so if I didn't make this a 3, this would be a 1-6 pair. And a 1-6 pair is not 1, 5, or 9. It's a 7. 7 plus 11 is 18. That's not divisible by 4. So this has to be a 3 in order to avoid that. And then now this has to be a 6 in order, because we can't add to 4. We can't add to 15. All right, anyway, so that's our 6. That's not a 6. That's not a 3. We get the 1 and the 3 here. This finishes the row with a 6. Let's clean these up. This is a 3 for the box. This is 6 for the box. And this is 1, 4. All right, so we're left with a bunch of 1, 4 pairs. So we need to figure out how this is going to sum to a multiple of 10. I think the easiest thing to do is just color these 1, 4s. So I'm just going to start here. Green, purple, green, purple, green, purple, green, purple. Okay. So on our line, let's add up what isn't a 1, 4. It looks like it's 9 plus 9, 18. So we have 18 so far. Okay, I think we can shortcut this a little bit because we know that the purple cells, there's 4 of them. They're all the same digit. So that's always going to be even. So far we're still an even sum. We need to be an even sum to be divisible by 10. And so now there's 3, no, there's 2 greens left. Hold on. I was looking at this one. These are also even. So no, that's not enough to do it. Okay, so we basically have 2 options, and I have to look at which options actually divisible by 10. So this is 18. If these added to 4, then that would bring us to 22, plus another 8 does bring us to 30. So that's a solution. We just have to prove the other way doesn't work. So 18, if these added to 16, 18 plus 16 is 28 plus 6, 30 plus 4, 34. And so then these add to another 2. That's definitely not, that's 36. That's not divisible by 10. So these need to be 1s. Purples are 1s. Oops. Purples are 1s. Greens are 4s. All right. Got it. We can get rid of the colors. Neat puzzle, Gene. That had some really neat deductions on it. And it's a constraint I haven't seen before. So it was fun to think about. But yeah, I think probably just the penciling that I did at the start to exclude those digits that couldn't be there gave us a nice boost. And then just thinking about evens a lot of the times was enough, except for this final line, which I had to actually check the 2 options. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.